With the NBA Finals in full swing this past week, I've been thinking a lot about what it takes for a player like Steph Curry to be such a consistently good shooter. The answer is likely a natural talent for rapidly evaluating the proper trajectory and velocity needed to put a ball through a hoop, combined with thousands of hours of repetition in many varied shooting scenarios. This got me thinking, could an AI do it better? The answer is somewhat obviously yes. An AI could easily be better than the best shooter in the world, Steph Curry. What's more interesting is how exactly we could arrive at an AI that performs better than Steph. This has implications far greater than just basketball. The question we're asking is how to determine the proper trajectory and velocity for a basketball from any given position on the court, accounting for factors like our current momentum and other players in our way who could block our shot. There are two general approaches that we could take to solve a problem like this, a closed-form solution or a learned solution. Let's discuss the closed-form solution first. The idea here is that we know enough about physics and the natural mechanics of our world that we could pass our position on the basketball court through a formula that would spit out the correct velocity and trajectory to shoot the ball. This is possible because we know enough fundamental information about our problem to solve it directly. However, the second way we could solve this problem, and what we're calling the learned solution, is much more similar to how Steph Curry himself learned to shoot a basketball so well. The learned solution involves trial and error. We put a shooting robot in tons of situations where it is forced to shoot the ball, getting feedback about how each shot went. Did it go in? Did it hit the rim? Was it way too short? Did it get blocked? Etc. And then based on all this feedback, we adjust how our robot shoots, making it better over time. If we keep our robot in a gym for thousands of hours, practicing tens of thousands of shots in every situation we can imagine on a basketball court, our robot would eventually get very good at shooting the basketball, possibly as good as the robot that shoots using the closed-form solution. We call this a learned solution because it involves our robot interacting with the environment over and over again to learn how the world works, just like humans do. The distinction between these two types of problem-solving techniques is crucial to what people mean when they refer to artificial intelligence. Many problems are already solved using closed-form solutions, and when we solve a problem in this manner, we generally refer to the solution as an algorithm. However, it's not always possible to solve problems with algorithms. Some of them are too messy and have too many unknown factors for us to ever come up with a closed-form solution. These are the types of problems that we typically need a learned solution for, and these solutions are what we usually refer to as artificial intelligence. The case of shooting a basketball illustrates the situations in which we use a closed form versus a learned solution. What we typically refer to as AI is used to handle the problems that are so complex that we cannot recover a closed-form solution. In these cases, we have no choice but to interact with our environment to learn a solution, just like humans do. In a future video, we will explore the specific ways in which AI can uncover these complex solutions.